This is our video for the lab physical properties and concentration, but before we get into the experiment, there's some background information we need to go over. So first, the meniscus. A meniscus is the curve seen at the top of a liquid in response to the walls of a container. And the meniscus exists because of surface tension and that the liquid likes to adhere to the walls of the container. And when measuring a liquid, you always measure to the bottom of the meniscus and always measure to 1 degree of uncertainty, meaning if I have the lines 1 and 2 and my liquid is halfway in between there, then I will call it 1.5, even though that's not marked on the measuring device.
In this experiment, we are dealing with stock solutions and dilutions. Dilution is creating a less concentrated solution made from a stock solution. And a stock solution is a solution that is prepared that you can make solutions of lesser concentration from it. The dilution equation is C1 times V1 equals C2 times V2, where C1 and V1 represent the concentration and volume of the stock solution, and C2 and V2 represent the concentration and volume of the diluted solution.
And this dilution equation can be manipulated to solve for whichever value is unknown.
The purpose of the experiment is to collect data that will establish a relationship between the concentration of sugar and the solution's density.
So we prepared a series of solutions with different concentrations. The best way to do this is to transfer some of the sugar stock solution into a beaker, then use a pipette to transfer a measured amount of it into a volumetric flask. We then added water to the volumetric flask until we reached the 25 milliliter mark. Now we have a diluted solution.
A good shot of V flask.
Since we were trying to relate concentration and density, we also measured the mass of the diluted solution, and we did this 3 times to get 3 separate sets of data.
Got 44.
Here's the data we received.
Use the equation density equals mass over volume to find the density of each solution. Here are our results.
And we use the dilution equation to find the concentration of each of our solutions.
We then graphed the results, and this is what we got. We also calculated the slope to find out how density and concentration were related, and our answer turned out to be 0.11.
I forgot volumetric flask. Page?
Yeah.